Hello, sorry if I didn't know it was going to cut me off, so I wouldn't have started the tangent part. If I would have known, I wouldn't have had time to finish. So I'll kind of talk about this tangent part again. So we said that 195 was 150 plus 45, and that tangent formula is tangent of 150 plus tangent of 45 over 1 minus tangent of 50 times tangent of 45. Okay, so we were looking at our unit circle, and we were at 150 over here, and that ordered pair is negative square root of 3 over 2, positive 1/2. And when you divide y over x, you have that fraction within a fraction. You can flip it over. You can multiply it. I'm flipping it wrong. Flip, multiply, cancel, rationalize. We get negative square root of 3 over 3. Now my favorite is tangent of 45, because 45 degrees is right here, and where our ordered pair is square root of 2 over 2, square root of 2 over 2. When you divide those, you get 1. Then we have 1 minus, and then that tangent of 150 again, which is negative square root of 3 over 3. So I have that negative negative becoming a positive, times tangent of 45, which is just 1. So you could just leave it like this. It's really okay. Negative square root of 3 over 3 plus 1 over 1 plus square root of 3 over 2. Really, you shouldn't leave a fraction within a fraction, and you shouldn't leave a radical in the denominator, but it's a pretty complicated process. And we could just plug this into the calculator and get a decimal, and that's really what we would want to know. Because tangent of 195 is going to be almost at 200. That's going to be just right about there. So really all we're asking for tangent is what is the ratio of this leg to that leg when you divide it. That's all that we're asking for. And this is actually the ratio, believe it or not. You can put it in the calculator and get a decimal here or a reduced fraction. Okay, the next part is using a sum and difference formula again to find the exact values of sine, cosine, tangent of pi over 12. So if pi over 12 being in radians is like, oh, scary, I don't know what to do. This is just half of pi over 6, so this is 15 degrees. How do you get 15 degrees? 45 minus 30, of course. So pi over 4 is 45. Pi over 6 is 30. So let's check that, getting a common denominator. So if I put pi over 4 over 12, that would be 3 pi over 12. And if I put pi over 6 over 12, that would be 2 pi over 12. And 3 pi over 12 minus 2 pi over 12 is indeed pi over 12. So we can use these and subtraction. All right, so how does this work? Sine. We alternate. Sine of pi over 4, cosine of pi over 6. He says their signs are the same. Sine of pi over 6, cosine of pi over 4. Okay, to the unit circle. So pi over 4, that y value is square root of 2 over 2. Pi over 6, that x value is square root of 3 over 2. Pi over 6, that y value is 1/2. And pi over 4, that x value is square root of 2 over 2. Final answer, square root of 6 over 4 minus square root of 2 over 4. Cosine. For cosine, Cosette likes to sit by her sister. So cosine pi over 4, cosine pi over 6. She says their signs are not compatible, opposites. Sine pi over 4, sine pi over 6. Same things, just in a different order. Square root of 2 over 2, square root of 3 over 2. Plus square root of 2 over 2, 1/2. So my answer is square root of 6 over 4 plus square root of 2 over 4. Of course, no room for tangent. Let's just skip it. No, I'm just kidding. Ha ha ha. All right, so let me write this again. What were they? Pi over 4 minus pi over 6. Okay, so tangent. Tangent of a difference, I subtract them in the numerator. So tangent of pi over 4 minus tangent of pi over 6. And then I have 1 plus, and then I multiply them. All right, tangent of pi over 4, my favorite, it's 1. Okay, pi over 6, we got to think about unit circle. That's here. So this is square root of 3 over 2, 1/2. So if I take y divided by x, that's that same one I did before. So y divided by x, flip and multiply. The 2's cancel, and then we have to rationalize. 1 plus 1 times square root of 3 over 3. So again, I mean, you can just leave it like this. Boom, done. Okay, recognizing sum and difference formulas. So when I look at this one, I have to look at the numerator when you have a tangent. This minus is going to match. So tangent of 250 minus tangent of 30, 1 plus tangent of 250 times tangent of 30. I know it's a minus because of the numerator, so I'm going to subtract those, and that's 220. When I look at this one, I see it cosine, cosine, so I know that's a cosine. In that story we listened to, watched on that little PowerPoint, we said that coset said, oh no, their signs are not compatible. They're total opposites. They won't get along. So if that's a minus, we actually have to add these, and that's 75 degrees. Okay, last thing is our double angles. Find the exact value. Okay, so these are different formulas. So the formula for double angle of sine is 2 sine cosine. So if I look at this, I don't know why that says a U, sorry, that should be theta. You're saying quadrant 1. So I have the sine is y over r. So y over r, using the Pythagorean theorem, I have a 4 here. So 2 sine cosine. 2 times 3 times 4 is 24. 5 times 5 is 25. To find cosine, I take cosine squared minus sine squared. So cosine squared was 4/5, so 16 25ths. And sine, no. What am I doing? Why isn't anybody stopping me? Oh, because I'm filming this video by myself. Y over R. What a ding-dong. I still set it up right here. Okay. Anyways, cosine is x over r, so squaring them, x over r, and then sine is y over r. So squaring 3/5 is 9 25ths. 6 minus 9 is 7. Okay, and of course, tangent. No one likes tangent. Okay, so our formula for tangent is 2 tangent divided by 1 minus tangent squared. Okay, so 2 times tangent. Tangent is y over x. 1 minus tangent squared. Tangent squared would be 9/16. So that's 6/4 over, now make this one a 16 over 16. So that's 7/16. Take this fraction, flip, multiply. Cancels to a 4, so 24/7. Okay, verifying. So what I want to do is I want to show that these theorems actually work. So it says sine of pi is 2 sine of pi over 2 cosine of pi over 2. So what's sine of pi? Go to your unit circle. What is the y value right here? 0. Okay. Now we want to go to sine of pi over 2. What's the y value here? Cosine of pi over 2. What's the x value here? 0 equals 0. Bada bing, bada boom. All right, verify that cosine pi over 2 is cosine squared of pi over 4 minus sine squared of pi over 4. Okay, unit circle. Cosine of pi over 2. What's the x value here? 0. Okay, go to pi over 4. What's the cosine there? Square root of 2 over 2. Go to pi over 4. What's the sine there? What's the y value? Square root of 2 over 2. What's anything minus itself? 0. Bing, bang, boom. Done. These formulas work. I'm not even making it up. All right, tangent at 360 is 2 tangent of 180 minus, I'm just too excited. 2 tangent of 180 divided by 1 minus tangent squared of 180. Okay, tangent of 360. So go to 360, worst circle ever. Okay, ordered pair here, y over x. Again, that's 0. 2 tangent of 180. 180 is over here. What's this tangent? 0. 1 minus tangent squared. What's 0 over 1? 0. Got it. All right, 5 different things that are equal to 1. I mean, oh my goodness, could you write anything in the freaking world? Okay, so how about sine times cosecant? Because cosecant's 1 over sine. What about cosine and secant? Yep, they're reciprocals too. So secant's 1 over cosine. Those would cancel out. Of course, tangent and cotangent. All those reciprocals. Those are all equal to 1 when you multiply. We have all of our Pythagorean identities too. Sine squared plus cosine squared. That's another one that equals 1. What else? Cosecant squared minus cotangent squared. That's equal to 1. Also secant squared minus tangent squared. Oh, and look at me, overachiever. I did 6. There's lots of things that will just completely cancel out. All right, good luck. Study, study, study.